Cusack, section 12, begins on page 57 of your book. This section is on correlation. Correlation, the extent to which two variables are related across a group of participants.
Contingency table. It depicts a possible relationship between the independent and dependent variables, and it's often presented in statistical research. It's used for interpretation and interpretation of data. Variables are in group data format. You generally, when you do this, you tend to use nominal or ordinal level of measurement. Again, the nominal level is like the naming level. It's like categories, like married, single, blue eyes, brown eyes, political parties. Ordinal level is, think of that as far as rank, like who's the tallest, who's the shortest. The tallest would be like a number 10 on a Likert score. The shortest may be example number 1. And that's just a refresher on nominal and ordinal data, and that's a type of data that you usually use for the contingency table. Constructing and interpreting contingency tables. First, I'll read this to you. We wish to test the hypothesis that the level of wealth enjoyed by a nation's citizens is positively related to the nation's level of political rights. I'm using these examples because for the following tables, to better explain those. So I'm using a textbook, that way you can look at a textbook. The next bullet point, the independent variable is an index of political rights originally developed by Raymond Castile. Castile's index originally ranged from 1 to 7, with the score of 1 going to the countries with the highest levels of political rights. To simplifying this example, countries are grounded into a 3-category ordinal scale, which categories of high, medium, or low. And you'll see this in greater detail in the next slides because he condensed them. Sirkin did. I should say this Castile guy. The independent variable, GPD capital, is the total value of all final goods and services introduced within a nation's economy, divided by the size of the population. A widely applied index of relative wealth. Look at Sirkin, page 151. Okay, we'll be working from this. As we go through slides, you'll see it, how this relates to each other. And if not, ask questions. You can send me questions as far as the tables. Regrouping variables. This is on Sirkin, page 153. I'm going to read this to you. The same words are on there. Look at the range of scores lowest to highest and create class intervals along this range. Do a frequency distribution of scores and examine that distribution. Then combine some of the class intervals with 2 objectives in mind. These are 2 things to keep in mind when you do this. A, reducing the number of class intervals to a manageable number, 3 or 4 categories. That's what it means, manageable number is in 3 or 4 categories, as they did for this data. And B, having in each category at least a few cases and, if possible, a roughly equal number of cases in each class interval. Rarely will the final breakdown meet the criteria for grouped interval level data as discussed in Chapter 2. Regrouping variables continued. To ease our task, we changed the scale of reflected units to 1,000. That is, as you see in your textbook, they divided each GPD by 1,000. Thus, for example, the U.S. score of 35,200 becomes a score of 35.2. So they reduced that so when you look at the contingency table, it's easier to understand and for individuals. The GPD capita in thousands of dollars range F equals, as you see on the table in your book. We may reduce the number of ranked categories, although in this case we cannot do so and keep our category size roughly equal. A preliminary frequency distribution might yield 5 categories labeled arbitrarily from very high to very low. You'll see this table in your textbook, Sirkin, page 153. We're going to look through this together. The columns would be what's from north to south, top to bottom, like pillars in a building. That's called a column. And the rows run from, let's say, east to west, west to east, across, like the horizon. So let's discuss the columns. The first column is entitled GPD, capital in thousands of dollars. Notice there's 5 categories here, which this will be reduced to 3 or 4, as you'll see. Well, I know, but we'll see as we go along. This will be reduced. The first is called very high, the second high, next medium, then low, and then very low. The next column to the right of this is entitled range. And notice this is reduced for the thousands of dollars, which is 30 to 35.2, which would be 30,000 to 35,200. And then for high, it's 20 to 29.9, which is 20,000 to 29,900. And then for the next one, medium, 10 to 19.9, and low is 1 to 9.9, and very low is below 1, which is below 1,000. And then you look to the right, both of these, the 2 next right columns are F equal, which is frequency equal. Notice the first one has they look like uppercase I's, which are 1 and 2, which like when you're keeping score, you put the lines down 1, 2, 3, 4, and if you're handwriting them, you know, like how they put the line across from lower corner to upper corner to mark 5, but in here it's just 5 lines as in high, the high one. So working across very high, frequency is 2, high frequency is 5, medium the frequency is 3, low the frequency is 6, and very low the frequency is 4. We may reduce the number of ranked categories, although in this case we cannot do so and keep our category size roughly equal. So they combine, let's combine very high and high. Notice that's what they combined on theirs, which that means the top categories you see on the next slides will be 7, which will be, they'll be condensing the very high and the high category. Okay, this is where they condensed high and very high, as you'll see on Sirkin, page 153. The GPD capital, we're reading columns from left to right, the GPD capital in thousands of dollars, high, medium, low, very low. Remember, they condensed the high and the very high to just be high. Now the range for this, the column to the right, for the high is 20 to 35.2, for medium 10 to 19.93, and for low 1 to 9.96, and below, and the very low is below 1, that's below 1,000. And the frequency for the high, as you see, is 7, the frequency for the medium is 3, and the frequency for the low is 6, and the frequency for the very low is 4. And as it states on page 153, this is in quotes, throughout this process, the researcher chose class interval sizes, cutoff points, and category names. You might easily have chosen other alternatives to the ones selected here. What they're saying is you could have combined this a different way. You could have combined it, besides combining high and very high, you may have decided to, for example, which would make it less even though if you were to have condensed low and very low, but then that would have been 10 on the bottom. 10 for the frequency for that. But they're saying there's more than one way of doing this. But this is an example of how you may have combined them. Now we look at how they did political rights, rank, and frequency. Notice the columns again, political rights, we have high, medium, low, very low. And then the rank, you have for high is 1, for medium is 2 to 3, for low is 4 to 5, and for very low is 6 to 7. And then the frequencies on these you see on the column right, for example, high, the rank is 1, the frequency equals 12, and medium, the rank is 2 to 3, the frequency is 2, and for low, the rank is 4 to 5, and the frequency is 3. And for very low, the rank is 6 to 7, and the frequency is 3. Look on page 154 of your text. That's where this is at, your Sirkin textbook. This is table 6.2. In quotes, I'm going to read what it has in the book. We used a similar procedure for the political rights index to produce a 4-category scale. We are now ready to construct our table. To do so, we follow a series of conventions used for table construction. By convention, we generally place the independent variables so that its categories become the columns, of the table, and the categories of the dependent variable become the table rows. When you look at the next slide, you'll be able to look at your textbook at these pages, and then it'll make sense as far as you'll see how they combine the two together. Notice on this table, as you look at the other ones in your textbook, look at this table 6.2, and see how they combine it. See across the top is the political rights, the breakoffs of them, which is high, medium, low, and very low. And you see that when you look across the top, you see those are the dollar figures. As far as the high is 20 or 20,000 to 35,200, and the medium is 10,000 to 19.9 thousand, and the low is 1,000 to 9.9 thousand, and the very low is below 1,000. Notice that's across the top. Those are the column headings. Now the rows, you see how that's entitled political rights, and that is from high to medium to low to very low, and it has highs in 1, medium 2 to 3, low 4 to 5, and very low 6 to 7. And it's looking across the high one. Notice how they put the frequencies of how many with the high political rights were in as far as the different categories, as far as, for example, those with high political rights, reading across that row going from left to right, the high GPD capital, which is 20.0 to 35.2, that's in thousands. Notice they have, how many they have on it? Let's see, 1, 2, 3, 4, 5, 6, there's 7. And then for medium, for those with high political rights, there's 3. That's your frequencies. There's 3 for that one. And for low, working to the right, for high political rights, there's 2. Now let's look at the next row, the column political rights medium, 2 to 3. You work across, there's 0 for high, the frequency for medium is 0, there's 1 for low, and there's 1 for very low, which again is below 1,000. And then the next row down, which is political rights low, 4 to 5, there's 0 again for high, 0 for medium, there's 2 frequency, or 2 for the low, and 1 for the very low, below 1. And then for very low, which is 6 to 7, notice again there's 0 for high, 0 for medium, 1 for low, and 2 for very low, which is below 1,000. Below 1. Once we have laid out the table, we examine each country in table 6.1 and go to the column of the table within which that country's GPD capita falls, and go down to the column to the row within which that country's political rights scores can be found. In the cell where the appropriate column and appropriate row intersect, we put a tally mark. That's those little lines you see. It's actually a capital I, though, on the keyboard. We continue with the process until all 20 countries have been tallied. This is on Sirkin, page 154. We're laying the groundwork as far as in your mind for this to make sense. The next, as we go on slide to slide, we'll be explaining more of this. This slide is table 6.2 in your Sirkin text, page 155. As you notice, they converted all the tally marks to actual numbers. You have the columns from left to right, political rights. Then you have the column high, 20.0 to 35.2, medium 10.0 to 19.9, low 1.0 to 9.9, very low below 1, and then the total column. As you see the total column on this, what that's doing is it's adding the row. That's each row total. For example, the high, the one, that's 7 plus 3, working left to right, 7 plus 3 plus 2 plus 0 equals 12. For the medium, again working left to right, 0 plus 0 plus 1 plus 1 equals 2. Working left to right again on the next row, which is entitled low, 4 to 5. That's 0 plus 0 plus 2 plus 1 equals 3. Very low, that's 6 to 7 for the political rights. That's 0 plus 0 plus 1 plus 2 equals 3. And now looking at the very bottom row one where it says total, notice the column political rights, there's high, medium, low, very low, and then the total row. What this total row is doing is adding all the numbers in that particular column. So for the high column, it's 7, working top to bottom, 7 plus 0 plus 0 plus 0 equals 7. Now for the medium, which is 10.0 to 19.9, it's 3 plus 0 plus 0 plus 0 equals 3. And for the low, which is 1.0 to 9.9, it's 2 plus 1 plus 2 plus 1 equals 6. Below the very low, which is below 1, working down, is 0 plus 1 plus 1 plus 2 equals 4. And that's how those are read. On to the next slide now. Again, I'm reading this from your textbook, Sirkin, page 155, generating percentages. When the category marginal totals of the independent variable are very close to one another, it is possible to interpret a table from the cell entries alone, as we did in Chapter 1. Often, however, this is not the case. The category totals are often larger numbers, and they differ, sometimes considerably, from one another. According to it is almost always advantageous to change a table from frequencies to percentages before interpreting the data. Percentaging in this manner has the effect of creating an equal number of cases in each category of the independent variable, so that trends in a table may be more readily observed. It is as if there were 100 high GPD capital countries, 100 medium, and 100 low. With equal numbers of cases, comparisons across the categories are easier to make. When you think of this, what they're saying is, to better interpret the table, we're going to turn them to percentages, and you're going to see how to do that. So we're going to turn those numbers into percentages. Notice on this slide, it's called Generating Percentages. You'll see this on the pages 155 to 156. First bullet point, consider the following table with the frequencies and its cell entries. The top and bottom rows increase as one scans from left to right. From left to right, notice the first is 8 and 15, and the second one is 2 to 85. Notice they increase in size. The next bullet point, if the table is percentaged so that each column adds up to 100, however, the relationship is far more apparent. Notice on here, they're changed to percentages. The 8 becomes 80%, the 15 becomes 15%, the 2 is 20%, and the 85 is 85%. And when you add those columns together, 80 plus 20 equals 100, and 15 plus 85 equals 100. Just stay with this. You'll see the table in the next one, how this works. The next bullet point, percentage means per 100, and the idea behind percentaging is to make the individual cell entries add up to a common base, a total of 100%. There are 3 ways to base our percentages, and most computer programs do all 3 for us, whether we need them or not. 3 ways to base percentages. Again, this is on Sirkin, page 156 to 157. There's 3 ways to do this. Number 1, treat each cell entry as a percentage of the grand total. For instance, if we have 7 cell entries in the high cell and table 6.3 and a grand total of 20, what you do is divide 7 by 20, which, as you see, that comes to 0.35, which is easier to understand percentages, so we convert that to a percent, which is 35%, which again is 0.35 times 100, or you bring the decimal place 2 places over to the right, and that becomes 35%. 2, treat each cell entry as a percentage of its row total in the high cell. 7 out of a total of 12 countries have high political rights levels. That would be 7 divided by 12, which the proportion would be 0.5833, which proportions are kind of tricky to understand. So we convert those to percentages, which you multiply 0.5833 by 100, and that equals 58.33%. The third way to base percentages is to treat each cell entry as a percentage of its column total. There are a total of 7 countries with high per capita GPDs, all of which have high political right levels. 7 divided by 7 equals 1.000. 1.000 times 100 equals 100%. The convention generally followed is to percentage so that each category of the independent variable sums to 100%. The independent variable is usually the one whose categories are the columns of the table, and thus percenting is usually such that each column of the table sums to 100. Stay with us. As we go, you'll see this play out more in the next slides. Okay, this is table 6.4 on page 158 of your Sirkin book. GPD per capita. You'll see this play out more here, what I was talking about. Notice they're doing it per column, the way they're presenting this. So the first column is entitled Political Rights, High, Medium, which is 2 to 3, Low 4 to 5, Very Low 6 to 7, and your total column, N equals. Okay, the next column is High, 20.0 to 35.2. Notice what they did here to come up with the 100% on the top. They took the 7 for the high for the row, and they divided that by the column total, which you'll see at the bottom. You go all the way down to the bottom, heading down, which is 7. So they did 7 divided by 7 is 100. And as you carry that down to the total row, that equals 100%. Now for medium, for high, notice that's the only one with the numbers. You go from top to bottom. There's a 3, there's a 0, 0, 0. So the 3 divided by 3 equals 100%. How you get the 3 divided by 3? Well, the high up top has 3 frequencies. And the total for that column is 3. So 3 divided by 3 equals 100%. Okay, now for the low one, this may make more sense because each one has a different number here. For the low, 1.0 to 9.9. Notice for high, the frequency was 2. So 2 divided by the column total, which is 6, equals 0.33333, which is 33.3%. The medium is, there was 1 frequency for the medium underneath the low column, low as in 1.0 to 9.9. That would be 1 divided by 6. 6 is the column total, which comes to 0.1666. That's rounded to 16.6%. The next row under this column is low, 4 to 5. The frequencies for that is 2. 2 divided by the column total of 6 equals 0.333333, which is 3.3%. Very low is 1 divided by 6, because there's 1 frequency for very low, 6 to 7, underneath the low column, 1.0 to 9.9. So that equals 0.16666, which is 16.6%. Notice the total here does not equal 100. It's 99.8%. The reason why it doesn't equal 100 is because we rounded, and the rounding loses the accuracy, so you can't get 100% for that. That's why it's not 100%. Now look at the far right column, which is very low, below 1,000. For the high, the political rights high, 1. There's 0 frequencies for below 1, so it's 0%. For medium, 2 to 3, the row, that's political rights, medium political rights, 2 to 3. And very low, below 1, it's 1 divided by 4 equals 0.25. 0.25 times 100 equals 25%. For low political rights, 4 to 5. Very low, below 1, is the frequency is 1. 1 divided by 4 equals 0.25. 0.25 times 100 equals 25%. For political rights, very low, 6 to 7, notice the frequency is 2. So what you do is 2 divided by the column total, which is 4, equals 0.5. 0.5 times 100 equals 50%. Now for this one, when you add them all together, it does equal 100%, because 25% plus 25% plus 50% equals 100%. Because notice we weren't rounding up the, for example, the proportions, which is 0.25. We didn't round it up before we multiplied it by 100. It was 0.25. Now interpreting, page 159, brief review of chapter 1. An inverse relationship will be indicated by clustering on the off-diagonal lower left to upper right. This sort of pattern is in a table is not the only pattern that indicates a relationship, but is the most commonly found pattern and is called a linear relationship. We will discuss linear relationships again later. Think of this inverse relationship when you're viewing your homework. Think of the different relationships we're going to talk about as far as your homework for Chapter 6. This is inverse, as an inverse relationship, page 160. Notice for the high column, reading left to right, it goes from left lowest percent to third highest percent to second highest percent to highest percent in the far right column. But notice for very low, when you begin on the left, it's highest percent, second highest percent, third highest percent, lowest percent. That's an inverse relationship, because if you look at the very left, low left, you notice it says highest percent for very low. If you look at the top where it's the high row and you go to the far right, that's the highest percent. So there's like a diagonal line there. And also if you look at the high row, the lowest is in the first column, where for the very low row, the lowest is in the far right column. Notice you could draw like those diagonal lines. It's an inverse relationship. The percentages in such a table may look like this, as you see here. For high and high, the high column and the high row, notice it's 2.5, and going to medium is 42.8 for high, and for the high row going to the low column it's 65.5, and for the very low column underneath the high it's 70.5. Notice when you look going down as far as on the far left column from high, medium, low, very low, and before the total column, notice the very low one on the high column is 77%, where the high column and the high row is 2.5. Now if you look over to the far right column, which is very low, for the high is 70.5, where for the very low column for the very low is 11.0. This is showing an example of the table again above this, what it would look like an inverse relationship. An example of an inverse relationship. No relationship, this is page 160. Suppose there is no relationship between the variables, and for each row we would expect the percentages to be the same or nearly the same, like about the same. You won't see much difference. The following is an example of where you have no relationship in your data. Notice for high, medium, the columns, which is in the darker blue, the darkest blue, high, medium, low, and very low. And then when you look at the rows, which is the rows underneath the far left column, you have high, medium, low, very low. Notice when you work your way across, for example, the high section, high and high is 60%, high and medium is 60%, high and low is 60%, and high and very low is 60%, where for the medium row, medium and column high is 20%, medium and column medium is 20%, medium and column low is 20%, medium and very low is 20%. We're reading left to right. The low row, working across the columns, the low row to high column is 5%, low row to medium column is 5%, low row to low row is 5%, and low row to very low row is 5%. Very low row to high column is 15. Notice when you look across, it's all 15% for this. Notice for each one there's not a change, for example, like the quote of the book. Here, 60% of all countries have high levels of political rights regardless of GDP per capita. 20% have medium political rights, again, regardless of GDP. And 5% have low political rights. And 15% have very low political rights for all four categories. Notice there's not a change based on the GPD for each individual political rights. So they're saying there's no relationship here, as you see going across. Controlling for a third variable, pages 164 to 165 of your Sirkin text. These are quotes from there. We've been dealing so far with the relationship between only two variables at a time. At this point, we explore the influence of a third variable, called the control variable, on the relationship between the first two variables. Later, we will discuss the exact role placed by the third variable. That is, it is also an independent variable, or it is another dependent variable. The next bullet point for now, however, let us merely explain some of the influences of a third variable. Third bullet point, control variable, a third variable that may have an influence on the relationship between the first two variables. We're placing the groundwork in your brain right now to build on this file for later as far as the control variable. Controlling for a third variable, page 165. I'm reading this. This is found in your textbook, word for word. In many experiments, one group of subjects, known as the control group, is given no experimental treatment but is compared to others who do receive treatment. For example, now I'm adding on the previous slide for the groundwork in your brain. You're testing to see if a treatment works. It's good to have a control group. For example, they don't receive the treatment. For example, let's say one group is receiving medication, an actual medication, a pill that has medicine in it for treating headaches. The other one, the control group, is receiving a placebo. They think they're getting the pill, but they're really not getting medication, true medication for a headache. People call these sugar pills or whatever. They're like a fake pill. There's no medicine actually in them, but the person doesn't, they won't realize that, for example, in what they call blind study. They won't realize they're not receiving medicine. And as you go on this, you'll be learning about double blind. That's, for example, the one giving the medication to both the groups. The regular treatment group and the control group doesn't realize who's actually receiving medication and who's not receiving the real medication. So basically, the control group, you'll find out more importance about them as we work forward on this. In the next bullet point, if we are studying the effects of time constraints on decision making, one experimental group may have no minutes in which to make a decision. A second experimental group may have 20 minutes to do so. But a third group, the control group, would have no constraints placed on it. If all three groups reach similar decisions, the researcher could argue that time constraints have no influence on decision making. If one or both experimental groups reach different decisions than the control group, the researcher could argue that the time constraints do have an influence. A spurious relationship, this is on page 166, in quote. It's quoted from your textbook, or income comma. We say that the original relationship between agriculture and telephones is an indirect relationship and, specifically, in this case, a spurious relationship caused by the presence of the control variable. Next bullet point, we use the term spurious when the relationship between two variables is the product of a common independent variable. That's what a spurious relationship is. Next bullet point, spurious relationship between two variables that is the product of a common independent variable again. Spurious relationship, control for, page 166 of your Sirkin textbook. I'll be reading this. This is quoted word for word from your textbook. Let us use an example in which a control variable functions as a second independent variable. We want to look at what happens to the relationship between a dependent and independent variable when we control for the influence of this new variable. By control for, we mean to explore the relationship between the initial two variables for each of the categories of our new control variable. In doing so, we can see the impact of the control variable on the initial relationship. Again, we're building the groundwork. When you do a study, you need a control variable. Notice I used medicine to explain it because it's easier to explain than the one they use in the textbook. As far as you need a control group, which is, I used the example of a placebo, a fake pill. You're seeing if it works to treat headaches. So one has the real headache medicine, and the other one has, they're taking a pill, but really it has no medicine whatsoever in it. And they're seeing, is it really the medicine that's helping the client get rid of their headaches, or the patient, or is it just the thought of them, or is it something else that could be contributing to the client's headaches going away? And again, this will go in further detail as the course progresses. Partial tables, page 167. There are two general outcomes that may ensure when the control variable is entered. 1. The control variable has no impact on the initial relationship. 2. The presence of the control variable changes the initial relationship or is necessary for there to be a relationship between the independent and dependent variables. Again, these are quoted from your textbook. Look at page 167 for these. In the next bullet point, we look first at the case where the control variable has no impact. To illustrate this, we generate two partial tables. Each one shows the relationship between attitude and gender for a specific category of the control variable. Assuming 120 white and 89 white respondents, we will have three tables. The initial table, the table for the white respondents, and the table for the non-white respondents. The first set of tables will be in actual frequencies. See table 6.9 in your textbook. Constructing and interpreting contingency tables, page 167. Table 6.9, race, gender, white, non-white, attitude on intervention, male, female, male, female. This makes more sense in your textbook. From my conversion programs, this looks a little odd. Look at page 167 of your text. Causal models, page 172. I didn't copy over the little diagram things, the figures from your textbook. So look in your textbook here on page 172. Causal models, schematic diagrams showing the independent, dependent, and control variables, and where appropriate, positioning the flow of causation of change in the dependent variable. Yeah, okay. Let's look at this. Look at your textbook. Figure 6.1. They put letters there to represent different things. For example, I is gender, and C is race, and D is attitude on military intervention. What they're saying is the individuals or the participants' gender and race, basically, biologically, these develop at the same time the attitudes, which shape, basically, roughly shape their attitude on military intervention. Notice how the arrows are both going from I and C to D. So basically they're saying that's what's going on here. That's just the basic explanation on this. And this will help go on to as far as then the next one. Look at figure 6.2 here. Notice figure 6.4 on page 173. You see a double-headed arrow? Those are between two variables, hostility and aggression. And they're pointing in opposite directions. This is saying that there could be, as the book calls it, as they say, indicate a reciprocal causation between the two variables. That's saying maybe one causes the other, or hostility causes aggression, or aggression causes hostility, that could work back and forth. That's what they're kind of saying about that. The next bullet point on the slide, antecedent variable, the variable initially leading to change in the dependent variable. Antecedent variable. Let's look at that. What's an antecedent? It's something that could bring about, for example, a behavior. In figure 6.2, 0.5, they show that I brings about, as far as the person's gender, determines the types of values this participant will develop when they're, socialized and stuff like that, which then affects, it brings as far as C to D. So in other words, the I, the gender, is the antecedent, brings the socialization, which is C, which is then intervening, which leads to D, by the way of C. Keep your mind open. We'll keep going through this. After looking at it a few times, it may start to make more sense. Here, again, the definition again in text, you see antecedent variable, the variable initially leading to change in a dependent variable. And the interceding variable is the variable through which the antecedent variable brings about change in a dependent variable. Causal models. It's a vocab for figure 6.6 in your textbook, page 174. Please look at your textbook because I don't have the diagrams, as far as the little errors and stuff here. For the first one, we're going top to bottom. I and C are concurrent. Notice that I and C are both leading to D. They're both leading together. They're not going via like. For example, the next one down, C is antecedent to I. Notice that C goes to I. It's the antecedent. It goes first. It affects I. And then the I is then the intervening variable. Notice it's between C and D. So C is the antecedent, I is the intervening, and then it leads to D. Where the next one down, C is intervening. Notice that in this case, the I is the first one, it's the antecedent. And the C is intervening, it's like the middle one before it goes to D. And for this one, the next one down where it says C is subsequent to D, that means that D occurs first. So first what happened is the I is the first one, which would be the antecedent in this case. The D is the intervening one in this diagram, where the C is a subsequent or the result occurrence of those. For the next diagram down, where it says C is irrelevant to the ID relationship, notice they have the little dotted lines going there. They're saying that it's not really, that C isn't really relevant to either the I or the D, that the I goes straightly to the D. Leave your mind staying open as you look through these. It takes a little bit of looking at them, and then after a while they start clicking in your mind as far as what's going on. Here, notice the I is the antecedent for both C and D. Notice the arrows come from the I and go to the C and the D. And for the next one down, C is both antecedent and the concurrent with I. Okay. This one, you see, the line goes from C directly to D, but the C goes to I, and then the I goes to the D. That's what, basically, as it builds up from the previous ones. So in this, it would be kind of like the C is the antecedent for the I, and the I is like intervening to D, where at the same time the C goes directly to the D. You see that on there. Where the next one, I is both antecedent and concurrent with C. Notice that the I can go directly to the D. And also the I goes to the C and then to the D. I is both antecedent to the concurrent with D. Antecedent to and concurrent with D. So, the I knows it's an antecedent for the D, and then the D leads to the C. That's what they're saying on that one. Computer applications, page 175. This is again quoted from your textbook. In this text, 3 sets of library programs for generating computer-driven output will be used. 2 will be introduced here, SPSS 12 and SAS 9.1. Later we will use Microsoft Excel. All 3 are designed for use using Microsoft Windows. All 3 are menu-driven and relatively easy to operate. Next bullet point, there are only variations of programs available for these companies and from many other firms. The examples presented here are illustrative and widely used in the social sciences, but by no means are they exhaustive, as in they're the only things. Your instructor may be modifying the information presented here for some other sets of computer programs. Computer applications, this is on page 175. SAS, a set of statistical computer routines, statistical package for the social sciences. SAS, a set of statistical computer routines and a programming language. This is statistical analysis system. The next bullet point, Microsoft Excel, Microsoft spreadsheet program that also may be used for statistical analysis. And the last bullet point, Microsoft Windows, Microsoft's widely used operating system.